This is a 99 Jeep Grand Cherokee 4-liter with 180,000 miles on it. A really interesting story. And the vehicle was towed in, and this is a different Jeep, but it's got the same engine in it basically. Towed in from a country garage, cranks but wouldn't start. It was backfiring through the throttle body while you cranked it. Boom, boom. Right? So for what reasons would it backfire through the throttle body? What can you come up with on that? If it's firing out of town. Like if it's got plug wires crossed. Or if you've got, I tell you, it's really weird on some of these little 4.3 liter Chevy engines with throttle body injection. If the spark plugs are fouled, but everything else is fine, it'll backfire out the throttle body. I've seen it blow fire that high out the throttle body because the spark plugs were fouled. It's just weird stuff. Lean backfires, you know, that causes the flame to burn at the wrong, burn too slow or whatever. Leak down confirmed head gasket blown between 2 cylinders. So he's done some checks, and he's found out that between 2 cylinders, he's got a burned out, see the blown head gasket between a couple of cylinders here. All right, so if he pulls the head off, he gets it rebuilt. Excessive warpage confirmed. Then he put your straight edge on it, use your feeler gauge. He found it warped. Machine shop flattened it out for him. Valve job, everything good. Reinstalled, nothing changed. Now that's disgusting, isn't it? I mean, he's found a problem. Did he sell them anything they didn't need? Remember that little thing I told you, I was telling Adam about that guy that brought that old mid-80s Ford pickup in there that had a fuel-injected 5-liter in it. First year they put fuel injection on F-150. And it was running terrible. I mean, it's absolutely terrible, and everything was bad. The crankcase oil was contaminated with gasoline, like it hadn't been changed in forever. And the throttle body was clogged up with sludge, and the idle air control was clogged up with sludge, and the throttle position sensor had a really ragged signal, and several other things, and I think the spark plugs were all burned up. Anyway, I went through all that. The guy okayed all that work. I went through all of that and drove the truck, and it ran really good. I was really patting myself on the back. He comes back with an intermittent condition a couple of days later, and when I checked it out, it turned out that the fuel pump in the gas tank wasn't feeding the one on the frame. On those old ones up until 1990, there was a fuel pump in the tank. It was kind of like a glorified windshield washer pump, you know, and it would feed the one on the frame, make sure that it kept it primed. Well, if that one would stop running every now and then, or if it didn't work at all, that'd be occasionally, you know, your big pump would lose its prime. Anyway, when I found that, he was thinking that none of the other work we did needed doing. I mean, so this is all maintenance stuff. It's obvious in your face stuff. Anyway, so crank sensor was next. He had an erratic signal on the scope. I'm getting a screwy signal on my scope, so I'm gonna put a crank sensor in. Went to change it out, found out that it was tire strapped in place. The hold down bolt had been broke. Extracted the broken bolt and reinstalled the sensor. So the bolt that was supposed to hold the sensor in there had been busted off, and they were just trying to keep the sensor in place. And if it's dancing around, you're going to have an erratic signal, right? It's supposed to be bolted in there good and solid, so he had to do a bolt extraction deal. And the left-hand thread drill bits work, or left-hand drill bits work good for that. If the bolt's not bottomed out in the hole or wrong threads or something, you can start drilling into that bolt with a drill bit turning backwards, and it'll catch and whoop, screw that thing right out of there. It's pretty handy. All right, now I got a clean signal on the scope, same no start condition, and now that's actually a scan tool screen there, so don't be confused by that. But looked into the cam signal with a really, really bad cam signal, so they wanted to replace that. This is how you set that. Now on those 4 liters, and I've talked about this in a few other presentations, if you on a 4 liter, like you're talking about there, it's got a cam sensor like that one, down there where the distributor used to go. You put it on 0 degree, make sure it's on compression, number 1, and you see on the balancer, you can line it up like that. And then you're gonna take and turn that, with it on 0, you turn that until all the holes line up. You remember when I talked about that before? Yeah, you line that thing up. That was a picture that I took right there. And that makes your cam sensor right. You can also do it with a scope, but I spent a lot of time getting one, you know, set with a scope, and then I went back and looked and checked it that way, and it was perfect. And I said I could have, you know, fixed it a lot easier. That's what it looks like on the scope when the cam sensor's right. On one of these Jeeps, like I'm talking about, you know, halfway between those 4 pulses, that cam signal will be making it switch right there. And then you can turn the cam sensor, and this will move on the scope and get it right. Got clean crank and cam signals, same no start condition. have a nice blue spark on all the coil packs. Every one of the, now this is one of them long coil packs that's, you know, about this long, and all of the boots coming off of it on the Jeep, you seen those? And the wires plug into the back that feed the, you know. And it's a pack like this, except it's just configured differently. You know, and you got some bolts down here, and you pull it out and all that. Okay. Pull the injector rail out. That's what they, you know, injector, that's fuel rail there. And it's all 2 injectors were not firing. Injector pulse was present on the 2 suspect injectors. So there was 2 injectors that weren't recording any fuel. See where we're going with that? This is a really dandy engine performance thing. I mean, he's actually uncovering stuff all the way through, from engine repair to engine performance, fuel delivery, cranking counts, everything is screwed up. I mean, this is a big long story, but it's going somewhere. All right, same no start condition. No, the timing is not quite right, the popping up the intake. That's what he's thinking, that was his thought process. Pulled the timing cover and found the chain was sloppy and jumped 2 teeth. Well, he's found out it has jumped 2 teeth. Now, everything he's done to this, has he sold these people anything he didn't need? No. Everything he's done needed to do it. And he's really getting some time into this thing. But you get to a certain point, you know, when you're somebody, if you're a person that likes to fix things, and if this thing can keep beating you up, you said, "This is me and you, man. You'll be gone, you know. And when you drive out of here, you'll be running like you're supposed to be." So he found out that the thing had jumped a couple of teeth. And so he does the timing chain. Very happy this was the end of the nightmare. Yay! We're going to get this thing out of here now. So he puts the timing chain on it. All right, ta-da! New chain and gears, realign the cam sensor drive, which was the little, you know, like I was talking about with the little piece there. Same no start. Nothing has changed. Just like it was, just like it was. All right, went over all the wiring between all sensors and the computer. Everything was great. Everything was like it was supposed to be. He's fixed a whole bunch of stuff that was wrong. Now thinking it has to be a computer malfunction or a used unit, used computer in the vehicle. And so installed it. In other words, there's another one that was laying in the seat. Somebody else been working on this thing, just trying to do whatever they could, you know, to fix it. And it's the exact same no start condition. Now we're completely lost. What are we going to do now, you know? I mean, if you get into troubleshooting some of this stuff, you can get here, you know. All right, ready to give up and ship it off to somebody else. Just set fire to this doggone thing. One last attempt. He Googled his problem to see if anybody else had the same issue, and he read a lot of stuff before he. This is a guy that it's on a Facebook page I'm part of. He told us this long story. It's a good story. You know what I'm saying? Somebody called that they had replaced the coil pack. Put a coil pack on it. That's interesting. We ran into this here, right back there in that service bay, when we swapped out a 4-liter engine in a Jeep Wrangler. Maybe the wrong one. The 99 and 2000 have specific coils for each year. What? Identical except for the plug angle and the internal wiring. So the internal wiring of that coil is different from 99 and 2000, even though they look just alike. Now I've seen that on these coil packs here, like on these Fords. Like if you've got if the basic rule of thumb is, if the connector is coming off this way, or if it's coming off this way, like if you try to put one it's where the connector's pointing up instead of one pointing out, it's not wired the same on the inside, and it will cut up and snort and backfire and act like you got your plug wires on wrong. Because these coil triggers are going in there in a different order. And the engine controller is firing them like this, you know. I mean, it's the same, that coil that's here. The engine is firing them in a certain order, but it turns out the order is wrong for that engine. So it's firing, you know, you got it wired up right, but it's not firing in the right order. In spite of the fact that, you know, the coils look just alike other than that. Well, this one right here, they look just alike. And so, that's what solved it into the months of stress. Without the help of the forum, you don't believe you'd ever found it. We figured it out on this one back here. But the question remains, how could this vehicle have had so many problems at the same time? All right, so tell me what you think about that. Which problem happened first? What was the chicken and what was the egg? The guy's driving along, you know, and the thing apparently had deteriorated over time. Probably it jumped a couple of teeth first. That was the base mechanical problem. Plus he had this blown head gasket. He'd probably been driving his head gasket blown for a long time. It was running kind of crappy. you know, and then they over farther more and more and more time, it jumped a couple of teeth all the time. And so they felt like, well, you know, we need to get this fixed. And so they went, whoever it was that worked on it before this guy was trying to do peripheral outside stuff. They were trying to do change parts. So they put an engine controller, they put a coil pack on there. You see, they just put the stuff on you could bolt on the outside really easy. And he started out working on the foundation, right? Let's see what we got. He checked the compression. He was looking at the engine, base engine health. Is what he's supposed to do anyway. And so when he got to the point where he discovered, you know, you got a smoking gun here whenever two cylinders don't have any compression, and you realize it's puffing back and forth from one cylinder to the other. I mean, he did everything right. You see what I'm saying? But he had no clue. He didn't have any frame of reference to know that from 99 to 2000, if you put the wrong coil on there, it's going to be like the wires were crossed and it's going to be popping out in the intake. Think about this. What if he discovered that right to begin with? What if he put the right coil on there to begin with? It would have started, but how would it run? Terrible, right? He fixed that one, putting the coil on it. We had one back here, and we put an engine in, and Taylor did it.
Richard?
Yeah, and so he put an engine in a Jeep Wrangler, engine and a transmission. We changed out both of them, and after he got it all put in there, it was popping and snorting and cutting up and everything. And the engine that they sent us, he put the coil pack that was with it, and it was a year out. And I told him, and I don't even remember how I picked up on this. I said, that's a problem with that coil pack. You get this other one off the engine that came out of this vehicle and put it in here. And at the time I thought maybe the coil pack was bad. So when we put the engine, other coil pack in there, boom, fired up. So we got, you know, sort of snappy and figured out. Now here's a 99 Mustang. All right, the symptoms are poor fuel economy, mill limp on, and it's always 3.8 liter, 232 cubic inch displacement, it's a 6-cylinder overhead valve, distributorless ignition, which is that, you know, that there, 4-speed auto. Okay, so this is his daughter's car. Service engine soon lights on, pulls the codes, got a PL 172, bank 1 rich. Got it? So you basically see in the oxygen sensor, you know, pumping at the top and the fuel trim's at the bottom. If the oxygen sensor goes up, fuel trim starts to go down, right? If it says I'm seeing rich, it keeps trying to pull it back the other way. All right, so look with the scan data, Dream found the fuel pressure reading at 70 to 80 psi. Well, checked with the gauge, found the same reading, figured the fuel pressure regulator. But is that always a problem? Is 70 to 80 psi a problem always? Hey, that light up there, that one right there.
Okay. You have to the other two out?
These are out on purpose. That
Okay.
that one's coming and going.
I'll probably check it at lunch when you go to lunch.
Absolutely. Won't be a
Thank you, sir.
problem. Thanks, Dave. All right. So anyway, fuel pressure regulator, that covering up and everything. So the deal was, what's the fuel pressure supposed to be on the Ranger? 70 to 80 psi. Just because it's 70 psi, 80 psi, if you hadn't looked it up, now this one here is supposed to be 40. He had a lot more fuel pressure than he's supposed to have. You know, and it's about that. You know, so he had a lot of fuel pressure. If you got a lot of fuel pressure, is it going to make it run rich? Yeah, I've actually seen the fuel pressure regulators, one with a little spring in them, and the vacuum hose. I would get some that would sometimes be puffing black smoke when I was working at the dealership. Put the fuel pressure gauge up to it, watch the pressure, and just tap that thing a little bit with my pocket knife, and the pressure would go wham, 100 pounds. You know, but it wouldn't always be at 100 pounds. Sometimes it would, sometimes it wouldn't. If you're checking to find a problem and it's only happening sometimes, what you need to do is you need to make sure that whenever you are checking it, you're watching the pressure while the problem's there. If it's cutting up on the road and you're not watching it when the problem's there, you're subject not to know what's going on. But if you got the pressure gauge stuck to the windshield where you can see it while you're driving down the road, if the pressure is the cause of it, you'll see something going on there. All right, so now we got this right here. Engine running fuel pressure is supposed to be 35 to 50. He's obviously too high for that, see? Key on engine off fuel pressure, usually 25 and 40. And you gotta kind of understand the particular fuel system too, what kind of fuel system it is. All right, so, yeah, then. Next started looking for the return line, thinking maybe it was bent, kinked, or whatever. Wait a minute, he says, this one ain't got a return line. Returnless fuel system. You see this fuel rail right here? The fuel rail right there. There's a fuel pressure regulator that goes on this one right here. Okay, and so the fuel pressure regulator's got a diaphragm and a spring. Pressure comes up in that rail, raises that little diaphragm against that spring, and it pulls a little pin off the seat and lets the fuel that's over 40 pounds or whatever go back in the tank. When there's vacuum on that diaphragm, it pulls up a little more and raises and lowers the pressure a little bit, right? About 10 pounds. Okay, can't find a return line. He realizes now he's working with a returnless fuel system where the pressure is regulated some other way. Now, this Cadillac that I was talking about, this Cadillac Escalade that had the, that's some sort of a, had a bunch of network codes and a traction control light on, and, you know, at the time, you know, we didn't really have time to deal with all that because we were doing other things. I said, take that thing over to the Cadillac place and let them see if they can reflash it or something. I didn't even look up any information on it. She comes back, she says, they say these are fuel pump, it's gonna be $1,800. Well, what the world? I thought you went over there with a traction control light and a bunch of network codes. She said, I did. They said it needs a fuel pump because the fuel pressure is too high. And I said, really? So, well, let's see what fuel pressure is. It was 160 pounds. But it still ran good. She didn't have any kind of lights for running Richard. I said, that's interesting. So we got a fuel pump for $400 and something. It's regulated inside the gas tank on the fuel pump. On that one, it's the return of the system on that Cadillac. It has a 07 Escalade. So we popped it in there, and fuel pressure went down to what it was supposed to be. Traction control light went away. Network codes went away. Figure it out, man. Automotive electronics, you know, what you think. Okay, so don't smoke or carry light in the backup, blah, blah, blah. Uses a returnless fuel system. Is equipped with a multi-point fuel injection system. Uses separately controlled fuel injectors for each cylinder. The fuel injectors are supplied with pressurized fuel through the fuel injection supply manifold. The fuel injection supply manifold is controlled. In other words, the pressure is controlled by the electronic fuel delivery module, which is enabled by the powertrain control module. The powertrain control module is what's going to be driving that fuel module. It actually reads the pressure on the fuel rail, like this one here does. This motor here has got a fuel rail pressure sensor, and it actually delivers more power to the fuel pump if it needs more pressure and reduces the power of the fuel pump with a special module back there, right? Okay, and it's sending the ground to the pump. It increases or decreases the ground of the pump. All right, looked in Mitchell on Demand, seems like this is a return system. Mitchell on Demand got that one wrong. They may have corrected it by now. He says, looking for help. Is this a return system or returnless? Well, if it doesn't have a line leaving the fuel rail going back to the tank, it's returnless. That little Dodge Neon that we had out here that Adam took over to Elba, that was a returnless fuel system. And right on top of the tank is basically the fuel pressure regulators right there coming out of the tank. You know. Okay, what's besides the regulator would cause such high pressure? Mitchell says 35 to 55, if memory serves correct, so we got back. Fuel pressure 70, coolant reading is room temperature. Key on engine off self-test, give me a P1237 code. Now here's a little deal here. Following the Mitchell diagnostic tree letting to measure the voltage between the tower and the fuel pump driver module and the fuel pump return line. He's got battery voltage. Mitchell says it ought to be less than 1 volt. Saying you got to short the ground in the fuel pump return wire, which is the ground, right? So if the wire that's supposed to be grounded by the fuel pump delivery module is grounded all the time, then the pump's going to be maxed out. So it's not going to be running, you know, various different rates to control your pressure. So the Easy Controller had no control over the pressure. It was expecting to be able to ground that. The fuel pump driver module, you know, couldn't do anything with the pressure because it was always grounded. All right, motor manual told him to unplug the fuel pump driver module and see if the fuel pump ran. It does not. They said replace the fuel pump driver module. No test for the fuel pump return wire. All right, this is what you're looking at right here. Fuel pump assembly there. And this right here is the part that the, you know, for your pressure sending and all that. But anyway, what I'm looking at here, I don't want to get bogged down on all that stuff. Fuel pump driver module's here. So it's got a ground here, and there's a shield right here. Look at that. Know that that's a shield. That's supposed to prevent outside interference from electrical interference from doing stuff to that little wires there. So they keep it shielded. There's your inertia switch. So if you hit something, you know, it'll flip that open and you won't be having any fuel pressure. Powertrain control module basically will send a signal here, and 3 and 10 are the two ones that operate the pump. So it's got total control over not only the power going to the pump, but the ground going to the pump. Now you can understand why you unplug the fuel pump driver module, it ain't gonna have no power or any ground going to the pump, is it? He ended up diagnosing it with a logic probe. Unplug the module and probe the fuel pump return wire, which is the ground wire, where the logic probe should show nothing, he had ground. Unplug the connector under the car just before the gas tank and still had ground. Alright, so he had ground on both the power and return wire for the fuel pump. Lowered the tank and the ground disappeared. Fuel pressure returned to normal, dropped the tank and inspected the harness and found nothing. So he puts the tank back up and the ground came back. So if the tank's grounded to the car, all of a sudden he's got ground there. See what I'm saying? At the module, what's that telling you? Shorted inside the tank. Okay? So pounding on the tank with his hand made the ground come and go. Boom, boom, ground comes and goes, comes and goes. So he replaced the fuel pump. The actual problem is that the fuel pump return wire inside the tank rubbed through the insulation and was grounded to the inside of the upper gas tank. The gas tank had grounded that wire. Moving the tank would move the wire enough to have the ground problem come and go, you know, especially if you also had it lowered so the tank wasn't touching the car. It won't be, you know, the ground would go away. That's the end of the story. You get that? Do you understand why I was telling you that? That's a pretty good little bunch of stuff there. I mean, those two right there, driving these guys crazy, but what they both had in common was they decided they were going to stay with it. Now, don't you think there were points, several points, where both these guys were really frustrated?
Mm-hmm.
What did they do? Did they get mad? Did they throw their wrench? There was a guy at the Ford place one time that used to get mad. He was easily frustrated, like some other people we know. And he threw a wrench in his toolbox because he was mad. And the lid of his toolbox was open, and the toolbox caught the wrench and threw it back at him, and it hit him between. I guess the toolbox was tired of being abused. That's a true story. But there was another guy. There's these two guys that I knew that worked over there. Both of them's names were Billy, but they were older than me, and they were older than me. And one of them was always picking at the other one. And one of them was dragging a big jack through the shop one day, and he was dragging this jack, had to go from one end of the shop to the other. And it was really hard to drag that jack. And he looked around, and the other guy named Billy was standing on the jack just riding it. Hey, get off my jack over here. All right, so that the guy that was dragging the jack was back there, and he saw this other guy, Billy guy, coming by, and he says, "Help me with this." And he said, "What do you mean?" He says, "There's something wrong with that windshield right there, right under where that wiper's at." You know, he had the wipers about halfway up the windshield, and he goes, "It ain't cleaning good. Can you feel that windshield right there?" And so he was holding the wiper blade up, and when he ran his hand out of the wiper blade, he let it go of the wiper blade, whack! So the guys were always doing something to one another, picking at each other. And they were both about the same size, you know, wormy little guys, you know. It's just so funny how they carried on with them. But anyway, that's something I wanted to let you guys in on, so you would know a little bit more about what it takes to, you know, just keep your teeth sunk into one until you get it straightened out. And that first one, that Cherokee, that would beat anybody up, because all the stuff that was wrong with it, you know. I thought that was a really good story there. All right, that's going to wind us up for today. I guess we can